Okay, guys, so this is the third problem, the B one, okay? So we have to analyze what we're having here, okay? If I analyze this, if I plug 1 into here, I'm gonna have 0, right? And here, what what am I gonna have here in the tangent? So in the tangent, here we have a function. This is tangent of pi over 2 multiplied by x. This is the function, okay? Just so you know. So if we plug this 1 that we have over here, here, this is the 1, I am having what? Infinite. Positive infinite. Way over here, okay? So I'm having infinite, right? And so then I'm gonna have 0 multiplied by infinite. What is that? I mean, what can I do? So that's wrong, okay? That's wrong. You can't do it. 0 by infinite is indetermination. So that's why we need to be quite. We need to have imagination, okay? So let me see it. Okay. So what happens? I'm just gonna say you an example. What happens if I tell you, okay, what is 2 over infinite? This is 0, right? And for L'Hopital, you need to have infinite over infinite or 0 by 0. So maybe we can have 0 by 0 if we have imagination, guys. Okay, so let me delete this part so you don't get confused. Perfect. What happens if I do this? Right? I'm gonna have, watch out here, 1 minus x divided by 1 tangent of p over 2x. Right? This is the same that we have here. Right? Yeah. Tangent p over 2x multiplied by 1 minus x. This is okay, right? I'm not doing anything wrong. And here I'm gonna have 0 if I plug this one here, right? So 0 over, you know that this is infinite. 1 over infinite, this is 0. Okay, so now I can apply what? I can apply L'Hopital. So this is very good. Very good here. Okay, so we can do the following, right? So we need to derive, let me do it here, d over dx of this expression and this expression d over dx, right? Perfect. But first of all, we can analyze this 1 over tangent. So let me do it here. 1 over tangent p divided by 2x is the same as having a, let me see, it's gonna be 1 over sine of p2x divided by cosine of p2x, right? This can be easily written as cosine of p2x divided by sine of p2x. I'm not dividing anything, right? I'm just making it more comfortable, the expression. This is good, okay? And this is the, yeah, okay. But this one can be what? Cosine p2x sine of p over 2x minus 1, right? And this is expression that I'm going to derive. Okay? This is expression. Of course, you can say to me that also we can have the derivative of this expression, but at the end, it's better this way, because here you don't have to remember, okay, what can I do? No, you just follow your intuition, guys. You can do it, man. You can do it. Okay, anyways, so let's do it. I'm gonna put this over here, right? Just over here. And then I'm gonna delete it, right? But just so you know. So this is the limit when x goes to 1, right? Of this 1 minus x, the derivative is minus 1, okay? That's it. And I'm gonna write, so you don't get lost, dx of this expression, copy of this expression, right? Perfect. Of this expression. Remember, this minus 1 is because I did this. So I just wrote it here, okay? Fine. So this is gonna be way a really big expression. Let me take this one over here. Okay. So let's do it, right? Multiplication. So I can say, because the derivative of cosine is minus sine of p2x by the chain rule. I have to derive this. Derive this is p over 2. Okay, perfect. Multiply by sine of p2x minus 1, right? Okay. I'm gonna derive this one, right? So this is minus 1. This is the minus. So it would be minus by the chain rule, minus sine 2x minus 2, multiply sine, cosine, p2x, chain rule, p2, multiply by the cosine of p2x. Is that I didn't have like more space here. Let me see if I can fix it, okay, guys? So you can be more comfortable. Let me do it this way. Okay, guys, so here you know that this is gonna be the limit when x goes to 1, right? And here I'm gonna take this and I'm gonna have more space here. I think it would be great. Let me delete this one. So this is gonna be cosine p2x. Perfect, guys. So we need to evaluate this thing, So let's do it. At the end, this one, if I evaluate 1 here, what am I gonna have? This is gonna be sine of this one is 1 minus 1. This is 1, right? 1. And this one is minus 1, right? And here I have p2. So what I have is the limit when x goes to 1 of 1. Sorry, here is minus 1. Minus 1. Here I have minus pi over 2 minus, so let me do it here. What am I gonna do it here? Here I'm gonna have this is 1, right? I mean, this is gonna be minus 1 over minus 2. But here is a problem. I mean, it's not the problem, but when I evaluate x equal to 1 here, cosine of p over 2, this is 0, guys, and this is 0. So all this expression goes to 0. So at the end, I'm going to have this expression. And the limit when x goes to 1, but here I don't have an x, right? So I can evaluate. So this is going to be 2 over pi. Okay, guys? So with this 2 over pi, right, I have solved my limit. So that's it. Thank you, guys.